Okay, I'm going to do a quick review of the Ferris wheel problem and the tsunami problem, just drawing your graph and coming up with your CABD, and then using that to make a prediction. The Ferris wheel problem, it says, as you ride the Ferris wheel, your distance from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts, your seat is at the position shown in the figure below. Let t be the number of seconds that have elapsed since the Ferris wheel started. You find that it takes you 3 seconds to reach the top, 43 feet above the ground. So this is important. 3 seconds, you're 43 feet above the ground. And that the wheel makes a revolution every 8 seconds. And the diameter of the wheel is 40. So let's draw a picture. So I have the Ferris wheel picture down here. And an important fact was that at 3 seconds, you were 43 feet above the ground. 8 seconds later, you make a full revolution. So if at 3 seconds, you're at 43, 8 seconds later, at 11 seconds, you're at 43. The diameter of the wheel is 40 feet. So that means if your highest point is 43, your lowest point is 3, simply subtracting. And then obviously, it goes around and around, but I'm highlighting one main wave. So now I'm going to list my CABD. C is your center line, and that would be this line right here in the middle. Perfectly in the middle of 43 and 3 is 23. 43 plus 3 is 46. Divide by 2 is 23. My amplitude, whether I go up or down here, is 20. My D value, where this is starting at, is positive 3. So I know in my equation, my D value will actually be negative 3. So I'm just going to flip it right away. My B value I find by using this formula over here. The period, or one loop, is 8 seconds. So 2 pi divided by B equals 8. Because I know the period in this. Then I will cross multiply. And when I do, I get 2 pi equals 8b. Divide by 8. And I will get b equals 2/8 reduces to 1/4. So that's pi over 4. So here's my CABD. And I also recognize that this is a cosine wave. So what I did was I graphed it. Now I'm ready to write my equation, which would be y equals, and these are in order, that's how I like to list them, 43 plus, it's positive cosine, so it's positive amplitude, 20 cosine, and a parenthesis automatically comes up, it's pi over 4, and then I'm all right if you use x minus 3 here. I do know in the problem that it said use t, but I know many of you are more comfortable with the x and the y. So there's your equation. And what you need to make sure you do then is be able to make a prediction with it. It says make a prediction of your height on the Ferris wheel after 60 seconds. Use your mathematical model. So I'm going to turn my calculator on. Make sure that I am in degree mode. In radian mode, which I am. And I'm just going to simply type it in. My equation here was 43 plus 20 cosine, then it's pi over 4. And then I'm going to put in, instead of the x or the time here, I'm going to plug in 60. And when I do, not sure if I put that in right. I'm getting 57. Well, this is kind of good that this happened. I don't know if you can see that. I got a 57, which is not a possible answer. The highest it is 43, and the lowest is 3. Let's see where I may have slipped. This is a cosine. My C value, oh heavens, look, my C value was 23, but look what I wrote here. So let's make sure I get that fixed. C value is 23. So let's go back up here, fix that. So my equation is 23 plus 20 cosine pi over 4 times 60 minus 3 comes out to be 37.14. So my answer It's 37.14 feet. So although I'm disappointed I made the mistake, it was kind of nice to show you that if your answer does not come out to be in your range, you made a mistake. So you might want to double check and make sure that you're okay. All right, so now we're going to look at the tsunami one. I'm going to flip it over. I kind of have my picture started a while. A tsunami, commonly called a tidal wave because its effect is like a rapid change in tide, is a fast-moving ocean wave caused by an underwater earthquake. The water first goes down from its normal level, then rises an equal distance above its normal level, and then finally returns to its normal level. The period is about 15 minutes, so I have marked that already. Suppose that a tsunami with amplitude of 10 approaches the pier of Honolulu where the normal depth of the water is 9 meters. So here is 9. This is meters. I should have all this labeled. And if the amplitude is 10, that means it goes down to -1 and up to 19. And it tells you that it first goes down and then back up and back to the center, all within the 15 minutes. If I look at that, I can see that it is a negative sine wave. So I know my amplitude should be written down as negative, which they said the amplitude was 10. I'm going to write -10 there. My C value is 9. It is starting right here at 0. And my B value, I'll use this formula again. My period is 15 minutes. So 2 pi divided by B equals 15. Cross multiply, 15B equals 2 pi. Divide by 15 on both sides. B is 2 pi over 15. Okay. So now the hard work is done. Good picture, got the CABD, I know it's sine. So I'm ready to give my mathematical model or equation. And please note that I did dash this here because technically that's the time where there's no water. But those are the minutes where you will see nothing. My equation is y equals 9 minus 10 sine 2 pi over 15. If you want to write x minus 0, you can. I generally just put the x there. So there's my mathematical model. And then part B, I'm making predictions by plugging in those values. Let's go back to my calculator. My equation is 9 minus 10 sine, and then it's 2 pi over 15. And the value I'm substituting in for x is 2, so times 2. When I do, I get 1.57 meters, which is right here. That's okay. That's within the range. I'm going to do the same thing. I'm going to go up and change my 2 to a 4. And that's when I get -0.95. That's in here. So technically that's when I have 0 depth. And then I'm going to go up and change it to a 12. And there I get 18.51 meters. So that's more up here. When it's up, I'll pull this down, excuse me, that's when it's up a little bit higher. So that is what is expected on your test. Thank you.